Hi, in this video we're going to be looking at anomaly detection using the Identify Unusual Cases procedure in SPSS. Now you'll find this procedure under the Data menu, where it's simply labelled Identify Unusual Cases. And indeed the procedure is designed to quickly detect unusual or anomalous records for data auditing purposes and often as part of an exploratory analysis. It works with both continuous and categorical variables, and as a form of anomaly detection, the procedure looks for unusual cases based on deviations from the norms of their peer groups. The peer groups are effectively a type of cluster group. So this procedure performs a type of cluster analysis in order to detect deviations from the norms of those clusters or peers. A few things to bear in mind. Missing values are allowed as part of the analysis, but any weighting applied by weight variables is effectively ignored. Secondly, the results can be affected by the order of cases. And to minimize the order effects, you might want to randomly sort the order of the cases. And in fact, if you're concerned about the stability of a given solution, you might want to obtain different analysis results or different solutions with the cases sorted in different random orders. This random effect is really an artifact of the cluster analysis that's being performed in the background in order to create the peer groups, which is a central part of the anomaly detection process. Ideally, the variables should be independent of one another, and procedures such as chi-square tests for categorical variables and correlations for continuous variables may help to determine this. Now, this procedure creates some key outputs, and it may help to start thinking about those before we actually run the procedure. One of the first things we'll see is an anomaly case index list. This is a table which shows which cases have been identified as the most atypical or unusual, along with their corresponding anomaly index scores. The anomaly index scores are a measure of how anomalous that record or that case is. The higher the value, the more unusual or the more atypical it is. You'll also see the anomaly case reason list. This displays the case identifier and the reason variable, the variable which is driving that anomaly score, along with the variable's impact value, the value of the variable for that case, and for comparison purposes, the value of its peer group norm for each of the requested reasons. And in terms of peer group norms, for continuous variables, scale variable norms table displays the mean and the standard deviation of each continuous variable for each peer group. And for categorical variables, the categorical norms table displays the mode, i.e. the most common category, the frequency and the frequency percentage of each categorical variable for each peer group. The example we're going to look at is based on some data that I've gathered from the World Bank website. The socioeconomic data related to 103 countries in 2015, and all of the fields that we're going to be working with here are continuous in nature. So here we have the data set open in the data editor in SPSS, and as we can see, each row represents a different country, and we have these socioeconomic measures, each of them being a scale variable. So we have things like a percentage of the population of access to electricity. We have income per capita, adjusted net national income per capita. Agricultural land use as a percentage, CO2 per capita. We have health expenditure as a percentage of GDP. We have fertility rate. We have homicide rate per 100,000. We have life expectancy of females. We have military expenditure as a percentage of GDP. We have the proportion of the female or percentage of female population aged under 14, and we have the percentage of the female population aged over 64, and we have the urban population percentage. Now, in ideal circumstances, we would want these fields all to be independent of one another, none of them to have really strong correlations with each other, because obviously to have that would mean that we're effectively measuring the same underlying factor. For example, we have income per capita, so that is adjusted net national income per capita. There's lots of different ways which one can measure this, but it's going to be highly correlated with GDP per capita. And if you were to put both of those factors into analysis, well, you're effectively biasing the analysis towards that type of measure, that type of thing. So if we wanted to explore the data before that, just to make sure, or just to see to what degree these variables are intercorrelated, we would probably do that with a correlation analysis. I think it's fair to say we'd be fairly naive to assume that all of these variables are completely independent of one another. I mean, obviously, things like the wealth of a country, income per capita, is probably going to be related to electricity percentage, and there may be other strong correlations here, which may give us pause for thought about whether or not we're going to include every single field in our analysis of unusual cases. But to look at the correlations, we just go to analyze here, of course. We go down to correlate, and we go to bivariate. I'm going to select them all. I'm going to ask it to only show the lower triangle and not to show the diagonal, which is just the correlation of the variable against itself. And I'm also going to ask it just to highlight the stronger correlations. So I'm going to say, okay, when you see a correlation that's, you know, greater than or equal to a value of 0.7, which is quite a strong correlation, I want you to highlight that in this orange color. And I'm going to add a second layer to it and say, okay, when you see a correlation value which is, let's say, lower than 0.7, but let's say higher than 0.5, highlight that as well, but use a slightly paler yellow color than the default here. Then if I click continue and click OK at that point, it's going to generate this matrix for me. If I double click on it, I can make it a little bit clearer again by clicking on the pivot menu here and calling up pivoting trays and saying just nest or put into the layer dimension the statistics, so that we're looking at just the correlation values, not the significance values, not the number of cases, just the correlation values here. And we can see instantly from looking at it that, you know, we have some very strong correlations. We have a really strong, the strongest one here is a correlation between the female population aged 0 to 14 or 14 or under, really, against fertility rate, which is really strongly correlated. And we might give us pause for thought about whether or not we should include both of these fields, because they appear to be measuring the same sort of underlying thing. It's interesting that there are variables here where there aren't very strong correlations. I mean, this variable here, agricultural land use, it has a negative correlation of CO2 per capita, but it's not a terribly strong correlation. It's just less than 0.3 here. We have some stronger correlations here which aren't highlighted. So 0.58 here of population ages 65 and above. That's the female population against current health expenditure as a percentage of GDP. But there are variables here like homicide rate, which, you know, none of the correlations appear to be greater than 0.3. So that's almost as interesting as the strong correlations that we're seeing. I'm going to, for the purposes of illustrating and for the purposes of the fact that these two variables are very strongly related to each other and they're above a correlation of 0.9, I'm going to just choose one of them. So I'm probably going to remove the variable female population age up to 14 and just include fertility rate. I've also got another measure of age relates to the age profile of the female population, because I've got a proportion here, proportion age 65 and above. So if I click at that point and return to the data editor, we can now look at identifying the unusual cases in the dataset. And to do that, we're going to go, of course, to the data menu here and then down to identify unusual cases. I've got the opportunity here to use a case identifier variable that will just label any unusual cases that it finds with the name of the country. So I'm going to send that across. I'm going to choose all of my fields and send them across except for the field population ages 0 to 14 female percent as a percentage of the female population, because of course, as we know, that's very strongly correlated already with fertility rate. And then we can turn to the output menu here and choose what type of output we're going to generate when we run this procedure. So one of the things we want to do is we want to say, what's the peer group norms? What are the, if you like, the average values for these peer groups, or the clusters that it's going to create, which identify, what is the peer group of that particular group of countries. We're also going to want it to produce an anomaly index measure, tells us how unusual a case is with respect to its peer group. The reason occurrence by the analysis variable, so it's going to say, look, this case is unusual, and this is why it's unusual. It's this field, and this is the score for this field in this case compared to the norm, or the average score, if you like, for its peer group. So we definitely want to see that. We want to see the reason, and we'll ask for cases processed as well. Switch that on. We also might, in the save options here, we can actually say save out a field which actually tells us what the anomaly value is for each individual case. So their anomaly index, it gives us an idea of how unusual are. We can also ask for the peer group and say which cluster effectively did they belong to. And in options here, we have control over how it identifies unusual cases. So the default is that it finds the cases with the highest anomaly index values, which is the top 5% basically. Alternatively, you can overrule that and say, look, just show me the top 10 cases. So it's always going to find some. It's always, irrespective of whether the cases are truly unusual or not, it just arbitrarily uses the anomaly index value and chooses the top 5% or an actual number that you give it. And you can say identify only cases whose anomaly index value meets or exceeds a minimum value. Well, I'm actually going to switch that off. I'm not terribly interested in that. You can see the number of peer groups, effectively the number of clusters it could create, up to 15. Not very likely to create as many as 15, but it has that option. And I'm actually going to ask it to say maximum number of reasons to show me for each. When we get to the reason table, to say show me up to 3 reasons why that particular country, that particular case was identified as anomalous or unusual. And then we run the procedure and we'll have a look at the results. Now, working our way through the output viewer results, and we're presented with a number of different tables. The first table that we encounter is the case processing summary. And this is simply telling us that the procedure resulted in 3 peer groups, or 3 clusters if you like. The first one only had 17 countries in it. That accounts for 16.5% of the data. The second one had 40 countries in it. That's 38.8% of the data. And the third one had 46 countries in it, 44.7% of the data. There were 103 countries in the entire data set. The next table we're seeing is the actual anomaly index scores for each of the 10 cases that we asked it to retain. We asked it to say, show us the 10 most anomalous, so the 10 countries with the highest anomaly index scores. We can see that Israel is identified as the country with the highest anomaly index score, 2.492, the most anomalous. And that, of course, is with respect not to all 103 countries, but to whatever peer group Israel has been assigned to. So it's with respect to its peer group, it's anomalous. Then we have Oman with a score of 2.1, then the United States with a score of 0.2, 2.074. So 3 countries have scores above 2. If I recall, in the dialog box, it did by default assume that you wanted to retain any cases of a score greater than 2. But in fact, we switched that off and gave it freedom to select just the top 10, irrespective of the score. So we can see right at the bottom here, we have Myanmar with a score of 1.428. The other countries are El Salvador, Singapore, Bahrain, Trinidad and Tobago, Sierra Leone and Luxembourg. Now at this stage, we don't know what's driving that anomaly, and we don't know which countries, which peer groups each of these countries belongs to. And we don't know what the mean or the norm scores are, so how much if they deviate from their peer group in terms of the variables that have driven this anomaly score. And lastly, actually, we don't know if we were to repeat this analysis, whether or not we'd get exactly the same results again if we sorted the data in a different order, because it is affected by the order of the cases. And in this case, the data was sorted in alphabetical order, which is fairly random anyway, because the alphabetical order of the country name. but we may find if we were to sort it in a different order, we might get a slightly different solution here. We might get different number of peer groups that are identified. We may get slightly different values here and different countries appearing in the anomaly case index list. But nevertheless, let's have a look at the remaining output and see what that tells us. So the next table we encounter is the anomaly case peer ID list, and here it's simply telling us that of the 10 most anomalous records that it's found, the 10 most anomalous countries, it's basically telling us what peer group they belong to and what size of that peer group. It's reminding us that the peer group was made up of 46 countries and that represented 44.7% of the data. If I actually resort the data or sort it in peer ID order, then it might be a little bit clearer of who's in which peer group. But you can see Sierra Leone and Myanmar in peer group 1, Oman, El Salvador, Bahrain, and Trinidad and Tobago are in peer group 2, and Israel, the US, Singapore, and Luxembourg are in peer group 3. Now moving on to the anomaly case reason list, which is the next piece of output, we're showing a very important table here. This is showing us what fields are driving the anomaly score for these 10 different countries that have been chosen. And we can see here that these fields are identified as the reason variable. So for Israel, it's saying that the first reason number 1 for driving that anomaly score is its percentage expenditure as a percentage of GDP on military matters, and that variable has a proportional impact on the anomaly score of 4.431. So that's really driving that anomaly score. It's the biggest reason why it's in getting that anomaly index score so high. We can see that the variable value, the actual average value for Israel is 5.44%, whereas the norm for its peer group is only 1.55. If we look at Oman, we can see that the variable impact score here of 0.418, that's driving its anomaly index score, also military expenditure percentage. Here the value for Oman was 9.57%, whereas for its peer group was only 2.26. Then we look at the US, we have health expenditure with a variable impact score of 0.386, 16% of GDP spent on health, whereas the variable norm is 8.5. El Salvador's homicide rate. Singapore is agricultural land percentage, where its variable value is only 0.9. So it, of course, being an island state, really doesn't have much agricultural land, and that's what makes it anomalous. So we're starting to form a picture of the various variables which are driving the anomaly score for these different countries. Bear in mind that this is only reason number 1, and we ask for up to all 3 reasons. We can look at the other reasons. If we just skip out to the output viewer here and double click on it, and we go up into the layer controls here, we can look at reason number 2. And we can see that the second reason that Israel is getting a high anomaly score, high anomaly index score, which is slightly less important, of course, than military expenditure, because the variable impact score here is 0.251. But nevertheless, it's fertility rate, and fertility rate for its peer group is 1.6298, whereas Israel's fertility rate is 3.09. For Oman, it's CO2 per capita, which is a variable value of 8.95, whereas its peer group's norm would only be 5. So we're starting to see the other variables which are driving these various countries' anomaly scores upwards. And we can drill down into them and view each one. So there's quite a lot of detail in this table. The next table we're introduced to is the scale variable norms. Remember, all of the variables we're using in our analysis here are scale variables. So this relates to all of the variables. And it's basically just telling us really what's the difference between the different peer groups, the different segments, because it's telling us what the mean and standard deviation is for each of these input variables. So we can see that, for example, peer group 3, 99.7% of the population have access to electricity on average, whereas peer group 1, it's 50.7%. Peer group 2, it's 95%. So If we're looking at agricultural land, it's 49% peer group 1, 37% peer group 2, 39% peer group 3. Interestingly, when we look at things like homicide rate per 100,000 people, we can see that for peer group 2 it has the highest value by far, 13.1 per 100,000. Peer group 1 only 4.4, and peer group 3 1.8. If we look at military expenditure, we can see the mean varies for peer group 1 of 1.59, peer group 2 2.26, peer group 3 1.55. If we look at things like percentage of urban population down here, we can see at peer group 1 37% of the total population in urban areas, 59% for peer group 2, and 74% for peer group 3. So it helps us start to understand what the differences are between these relative clusters, these relative peer groups that it's created, and what their profile is. And lastly, we come to a series of 3 tables, each one related to the 3 different reasons that we asked it to report back on, which simply tell us how often the different variables occur within each of the reasons. So we can see here, for example, that if we're looking at reason 1, how often among the 10 anomalous countries we asked it to select for us. In fact, access to electricity and income per capita never occurs within reason 1, whereas CO2 emissions occur 3 times out of 10, current health expenditure occurs twice out of 10, intentional homicides only occurs once, military expenditure occurs 3 times. It's telling us what the minimum and maximum values are of each of these groupings, because of course if they occur once, it's going to just refer to one country, in this case El Salvador, and the minimum maximum is going to be the same. But if there's 3 countries where military expenditure has been mentioned as reason 1, then there's going to be some variation here that ranges between 2.96 to 0.431 with a mean of 3.382. For reason 2, we can see that how often things occur, like fertility rate occurs twice in reason 2, urban population occurs once, access to electricity does occur once in reason 2, net income per capita occurs once, and agricultural land occurs once in reason 2. Of course, we know that's related to Singapore. And then reason 3, it simply tells us how often each of these variables occur. Again, in reason 3, agricultural land actually occurs 3 times, health expenditure occurs once, military expenditure occurs twice, and population ages 65 and over for the female population occurs twice. And finally, we should remember that we actually asked this procedure to save some new variables for us, and it's created these extra variables, add them to the end. Here we have an anomaly index score, which shows the score, the anomaly index score for every single country in the dataset, as well as their peer ID, what peer group they actually belong to. And of course, if we were to sort this in descending order, we would expect to find Israel at the top, followed by Oman, followed by the United States, the peer group IDs. We could try and illustrate this. We could use this variable perhaps in some routines and some modeling analysis, etc. But we could illustrate it maybe using something like a box plot. If I go to graphs here and go to chart builder and down to box plot, I can ask it to create a box plot where 3 separate box plots, in fact, for each peer group, for each segment it finds, each cluster, and it to display the anomaly index, to show us the shape of the distribution for the anomaly index, and maybe even to add in a point ID here, so we can add in country name. Remember that box plots work on the basis of percentiles, where the box itself is the middle 50%, the bottom from the box to the bottom part is the bottom 25%, and then from the top of the box 75th percentile up to the top is the top 25% minus or excluding any outliers or extremes that it finds. So these are independent of the anomaly score itself. It's not choosing anything above a certain anomaly value. It's simply saying relative to the other values in the cases it can identify outliers and extremes for us. And when we run this, we can see that here are the 3 peer group IDs. You can see peer group 1, actually for peer group 1, nobody is technically an outlier or an extreme value, whereas in peer group 2 we have 2 outliers, Bahrain and Trinidad and Tobago in terms of their anomaly index, and 2 extremes, El Salvador and Oman. And for peer group 3, 2 outliers, United States and Singapore, and 1 extreme, which is Israel.